Hello and welcome to the sixth lesson in Spiral 4. So today we're talking about graphing nonlinear relationships. So I want to be able to demonstrate understanding of how to graph nonlinear and interpret the information from the graph. All right, so we're going to be able to graph them and then interpret. So this one involves an investigation. Now, unfortunately, if you're watching the videos, you're not going to be able to do the investigation unless you ask your teacher. And this would be a good time, if there's time permitting, that you ask your teacher to get the material and try it yourself. So basically what we're doing is we're just making a pendulum, and we're changing the length of the string on the pendulum and collecting the data. So if there's time, I'm not sure whether there is time, you'll have to ask your teacher. You can try this. However, I do have my results from the class that we worked with and did this together with. So I'm going to fill out final answers here. So for the lengths 10, 20, 30, I'm going to average it for us and save us some time here. So average time was 6.3, 9, 11, 12.7, 14.2, and 15 and a half. Okay, so there's our average times. Describe the trend. Okay, so in this case, when you do a scientific experiment, it's good to do the graph first. All right, the table of values is only so good if it's not exact. And the previous ones we've been working on, those values have been exact, but average time, we have decimals now, and they're being averaged over three trials. So this is where you have to go ahead and make the graph. You don't really have an option here. So on the x-axis, we are going to go with length, and it's going to be in centimeters. And then on this side, we're going to have time, and that's in seconds. So up the y-axis here, for time, I can go by ones. For length, I'm going to go by fives. So here's my 10, my 20, and up here we'll go by 1, 2, etc., etc. All right, so I'm going to plot these points as best I can with the smartboard. So 10 centimeters was 6 seconds. So 1, 2, 3, 4, 5, 6. At 20, it was 9, 7, 8, 9. At 30, it's 11. So that was 9, 11. At 40 centimeters, 30, 40, it's 12 and a half-ish. So that's 11, 12 and a half, 12.7 in there somewhere. 50 is going to be at a little over 14. So what am I at? So that's 30, 40. So here's 50, and it's at 14. So that's 13, 14. Okay, and then at 60, we are at 15 and a half. So about there. Okay. All right. So if you had your ruler handy, I'm going to use a line here. If I go to connect these dots, it's close. Okay, it is close. But when you take a step back and you look at this, you can see that there seems to be a natural curve to it. Okay, so if I was to grab my points and connect them with a smooth curve, I would say it looks like this. So it is a nonlinear relationship. So you got to be careful. Could it be linear? You could force it, but really you need to take a step back and say to yourself, you know what, I do see the curve in it, and that's what the curve looks like. So there is the graph of our relationship, and we can move this back then. So continuing the curve back, I'm going to go back to something that looks like that based on my curve. All right, I don't know how accurate it is. Describe the trend. So this is definitely a strong, non-linear correlation. All right, it's not linear, but it is strong. Does this show a linear relationship? No. How do you know? The points result in a curve. Okay, we can see that curve forming as we sketched it in. All right. Suppose you had made the pendulum 35 centimeters long. How long do you think it would take to swing 6 times? So this is where I recommend, you get your ruler out. I'm going to do it in a different color. So first thing we're going to do is find 35. I guess that's the first thing we need to do. So 10, 20, 30. So here's 35 on that line. So what you would do, you take your ruler. I'm going to do it in green. You draw a line up to where it crosses our curve, right there. So that's the important part right there. Then you take that ruler, turn it around, and we shoot it across the x-axis, and we figure out what the value is. So counting up. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like 12 seconds to me. So at a length of 35 centimeters, the time would be, I think I said 12 seconds. How long do you think it would take to swing 6 times? Suppose you had to make how long would it, 35 centimeters long. All right. How long do you think it would take to swing 6 times? Right. I see what this question's asking. All right. So this is, again, this is the time for one swing. All right. So how long it takes for one swing to occur. So if you're going to do it 6 times, so therefore 6 times 12 equals, it's not going to be 272 seconds for 6 swings. So that's going out and then coming back in. All right. What problems did you experience? What other factors may have influenced the swing time? Is there any way you could test out your theory? So this is just talking about, and this is tricky when you didn't do the experiment. So what are the problems when you do an experiment like this? All right, these points, the numbers up above here, I took from an entire class. So some of the problems that we run into are human error. All right, and that's around the timer. You can only hit that button at the right time each time, so there is human error involved. All right. There could be measured incorrectly, so again, that's more human error. So timer, measuring, or measurement. Oops, measurement error. So you didn't exactly measure the right length of string for the pendulum. All right, but you'll notice the majority of this is going to be human error. Okay. I can't think of any of the other ones. Is there any way you could test out your theory? Well, there is an actual equation to determine this. So you could test it against the actual equation. So you could test your results with the equation. All right, and this is one that does have an equation. You can test it out with that. All right. So again, this was an experiment. So this would have taken the entire period to work our way through. In the end, all we're really doing is practicing taking our own data and graphing it to see firsthand what it looks like when it's not linear. Again, it's good practice for identifying that it's a gradual curve. So in this case, if you have any questions with it, it's pretty tricky to answer this unless you do the lab. Try the assigned work, and if you have any questions, make sure you ask your teacher for clarification. We'll see you in the next video.